Vectors are measurements that have both magnitude and direction. Displacement, you can say 3 meters to the right. Velocity, you could say 3 meters per second eastward. Force, you could say 3 newtons downward. Acceleration, 3 meters per second upward, or 3 meters per second squared upward. All of these make sense because there is both a magnitude and a direction. Because a vector is a quantity that has both magnitude and direction, it can be represented by an arrow. The length of the vector represents the magnitude, and the arrow indicates the direction of the vector. Here we have 4 vectors pointing in different directions at different sizes. The blue and the orange vectors have the same magnitude, but different directions, so they're both the same length. The blue and the green vectors have the same direction, but different magnitudes. The blue and the purple vectors have the same direction and the same magnitude, so they are equal. 2 vectors are equal when they have both the same direction and magnitude. Here is a good example of what a vector would look like used in physics. The direction of the vector is 55 degrees north of east. The magnitude is 2.3. Now for our usage, 95% of the time you're going to measure the direction of the vector from the positive x-axis, counterclockwise from the positive x-axis. There are various ways to add vectors together. There are mathematical methods, or there are graphical methods. We're going to use the graphical method called head to tail or tip to tail. You have vector v, vector w. You have the initial point where v starts, and where w ends is called the terminal point. V plus w is a vector that goes from the initial point to the terminal point. Here we're going to talk about negative vectors. The negative of a vector is just a vector going the opposite direction. A number multiplied in front of a vector is called a scalar. It means take the vector and add together that many times. Here is how you might add vectors in a typical physics scenario. You have 2 vectors that you wish to add together. They both start at about the same place. Move B so that the head of A touches the tail of B. Now moving B does not change the vector at all. A vector is only defined by its magnitude and its direction, not its starting location. The resultant is what you get whenever you add the vectors together. Here you have vector C, which equals vector A plus vector B.